All right, so I guess we'll start right now. Sorry for the delay. I was trying to set this up. Basically, what I'm trying to do right now is after we go through this lab, I'm trying to see if we can, get like a short demo with the vehicle doing going here autonomously. And I haven't tried it yet, so we'll see how that goes after this lab. But we will be using the simulation for this like a workshop. So it should work on your simulation, as you go along with the guide that I will give you guys show you guys later. And another thing as well is this is we're doing this today at 7 just because Friday I will not be here, so I was like I'll just do this early and record it. So like that, if you can come here and do this workshop, that's fine. But for the people that couldn't make it, I'll record everything and post it, so it, and you guys can also take a look at it later as well to go along, like to understand it better. So I will go over this presentation about like PID control and wall following technique as quick as possible, pretty much. And I will also post this presentation, so feel free to take a look at it later if you have questions, something, or whatever that you need. And for you to be able to kind of do this workshop, there's like three things you need to have. You need to, have VMware running Ubuntu with ROS. You need to have the simulation setup. I think those are like the three things that you pretty much need. And of course, being a bit familiar with ROS is very helpful. But the guide for this workshop, just like the last ones, will be the step-by-step guide will be kind of like sent out later. So even if you didn't are not able to like follow through perfectly, you can kind of at your own time go over it later. So let's start real quick. Oh, of course, sign in if you haven't already. All right. So this is also the form from last workshop. Basically, if you want to help out with the comedy, any of the comedies. Currently, we have three, which is sponsorship and industry liaison comedy to kind of like help us get money. The other comedy is PR and marketing, to help promote AI research, the workshop, the competition. And then we have the workshop comedy to kind of like help us run these workshops overall. And then we do have one position open, the industry coordinator position is open. So if you feel like fill out this form if you're interested in helping us out at any level. All right, so I guess let's start pretty quick. So, you know, overall, what is autonomous navigation? So for autonomous navigation, you need three main things, which is perception to kind of like see what's around you, planning, which is knowing what to do with that information, and control, which is how you actually move. You make the vehicle move. So, what is wall following? So, wall following is a technique that also called corridor following or edge tracking, boundary following. So basically, that technique allows a autonomous systems to navigate inside of a known place by simply following along the side of the wall or like the side of obstacles. So it doesn't know where it's at. So and it wants to move, it just kind of like try like track the side and then follow along at a safe distance. You know, just kind of like this robot is doing. And then the entire thing is it's really two main thing. follow along at a set speed, at a at a set distance from the wall, and try to be as parallel to the wall as possible, so that you can actually follow it. Because if you're not parallel, you will run into the wall and all that. So there's that. And why you would need that pretty much is that, like, you might not have a map of a place that you're going. If you're racing, you might not have the map of the track. You might want to be able to try to like create a map, or you might want to like solve a puzzle, or like all of that, a maze. All of those things might require you to implement a wall following method. And that's kind of like the whole point of this workshop is to try to like help you implement that technique. And the problem is, you have the car driving. You constantly need to be able to tell the car how fast it needs to go, and constantly needs to be able to tell the vehicle, like, how how it should steer, the kind of like the tires, the front tires, the steering wheel. So this is kind of like the summary of what I said. The goal is to stay centered in the corridor, or like stay parallel to the wall. And the two things you're controlling are the steering angle and the velocity. And the things that you will need to take into account is how far you are away from the wall, and what is the actual orientation of the vehicle. So of course, these are some kind of like a math math input. We will not go too deep into it. Basically, the reason we need to have, like, we're using sine or cosine is because, let's say, the vehicle is going at an angle. You need to be able to know how far it is away from the wall. The vehicle is away from the wall. You would need to, use the sine component to find the the y component, like this distance, basically. So you would need to use sine. If you know that distance, then you pretty much, this time sine the angle of that will give you how far you're away from this. So this is kind of like just a heads up, so that when you see it in the code, you're not kind of like confused. And the what we want is, like, let's say this is the line that we want to kind of like follow, or the vehicle needs to follow this wall. But as you know, nothing in this world is like precise. You will have a lot of thing that you need to take into account. And you might end up having the vehicle doing this, and what we want is for it to be as short as possible from the desired temperature. So control theory, like, a quick brief introduction to that is that, when you hear about set point, when they say set point, they're just talking about, like, the desired value. Process variable is like, what you actually get. Error is like how far away you are from that value. And when you hear plant, they're just talking about like the entire system, the car. And when they talking about actuator, it's like the steering and motor. And the sensor is like the lidar. The reason I include this is because if you end up like looking more into it later, you might see those terms, and this is pretty much what they mean. And when when it comes to control, right, here's like a two main type of control. You have open loop control, which is simply, uh, you have an input, it gets processed, and you have an output. That would just mean you have the vehicle, right? You tell it to go 45 degrees, and it goes 45 degrees. That's kind of like the output. So this is like open loop control. However, in the real world, if you tell a vehicle to go 45 degrees, it will most likely not do 45. It might be like 43, 47, like, all of that. So that's why you would need some form of like closed loop, which is a feedback control. So basically, it's like after the vehicle try to do 45 degrees, you have a feedback loop that tells the computer, actually the vehicle did not do 45, it did 47. And then the computer is like, oh, so there's like an error of like 2 degrees. And then based on your like what you would want to do with that, your algorithm, based on that error, you kind of like change the next input, or like the next command. So we can skip that. And so this is where PID comes into place. So PID allows you to take into account the error that you have on the feedback loop. And PID has three main components. You have the P, the I, and the D. P proportional, I integral, and D stands for derivative. So when, let's say, like you see this graph right here, the dotted line, the dash line would be, what you would want the vehicle to do, or like whatever you would want something to do. And then P is like, okay, so it try to do it, but it's like, that far off. So you increase P so that it try to like adjust where you want to be to, like, what it actually is. However, as you're like increasing the P, it will try to oscillate. So for that, you would need to like increase the derivative parameter. And also, if it's like an offset, if there's like an offset, if it's like going this way instead of like going here, you increase the I parameter. So a quick show of how it would work on our vehicle with PID overall. So if you have this line it wants to follow, um, as you're like messing around with P, it will try to like oscillate, and the goal is to have it oscillating around this line. And then after that, you will adjust the derivative control, which will try to like make it be as close to the line as possible. It's more of a damping thing. And then integral is like if it's offset, if it's like, okay, it seems like it's going straight, but it's not on the line, then you increase the integral part so that it's on the line. So this is the formula for it, and it might look a bit like intimidating, but this is all it means. It's like so the error term that I mentioned before, it's like your actual input minus what actually the vehicle what the vehicle actually did. So basically, you would have a random, not a random variable, like a variable. This is the variable that you will be adjusting to fine tune your PID, and then this is the error. So with the differential part, so that's the proportional part. The differential part, this is pretty much how fast your error is changing. So so that's just what that means. So as you are continuously getting, you have an input, you get a specific amount of error, you adjust your input based on that error, you get another one, all of that. So based on how fast your error is changing, this is the differential part. And then integral part, this is just adding up all of your errors. So if you do want to get, more in depth with that, you can kind of like do that later on your own, or going more on the rest of the slides. And basically, to fine tune your PID, some things to keep in mind is that if the vehicle is like sluggish, you need to like increase the P parameter. If it's like oscillating, it's because the P parameter is too high. If there's an offset, it's because the I parameter is too low. And then if it's kind of like just kind of like messing up, like it just would kind of like do a big turn. So this is because the I is too high, and then you will have overshoot and noise amplification. So you will just adjust the derivative parameter. Uh, so this is kind of like an illustration of what we would want. This is the distance that we want to follow from the wall, and we will want the vehicle to go straight. And you will have your lidar on the vehicle. And in the last lab I showed you like how the lidar works. It's 270 degrees, so from here to here. And let me skip all of this parts. So this is more the technical, like a version, if you want to understand how it truly works. And so this is an example of how you would want to fine tune your PID controller. So as you can see over here, you have the P controller to set to 5, and the vehicle will be oscillating a little bit. So obviously you don't really want that if you're racing, because that's like you're losing a lot of track. Even if you're like navigating overall, you wouldn't want that. And this is explaining how you would need to like adjust the derivative controller and what it does. So the derivative controller is just kind of like a damping. So it's like to avoid it from oscillating like it's doing right now. The goal for the derivative controller, oh, we are approaching from the set point. Let's reduce the the input so that we don't overshoot. Overshoot is like you there and then you still continue to go. So that's what the derivative controller is doing. And this is an example of once you set the derivative controller to this amount, at least for this system, now you see like the vehicle is kind of like going better overall. And then with the integral controller, it's it's like let's say if over here in this video right here, if once it kind of like settled down, right now it's a bit on the track, so it's fine. But if it was like if it settled down and then the vehicle was offset by by the same amount, like like it was just going straight like over here instead, then you would need to like do fine tune the integral controller, and that would fix the problem. However, in this case, we don't really need it, and you don't often need it, so that's something to keep in mind. And let me show you something real quick. So this is what it would have done if like this is if it's offset. The black line is like it's going straight, but it's like offset, and then you adjust it a little bit, and then you would allow it to be like more straight. However, in this case, we didn't need it, and you will see that when we you know increase the integral controller, the vehicle just kind of like crashes. So that's just something to keep in mind when you are doing your when you are fine tuning your algorithm. So this is showing how the lidar pretty much works. So it starts from negative 135 degree to 135 degree, and our lidar goes has a maximum distance of like of 10 meters, and we will pretty much use that lidar to get the distance, and use the trigonometry to get the distance of the vehicle from here to like here. And as the vehicle is moving around, you will continue to um to try to like get that distance, distance b. So we need to figure out b, and we also need to figure out how what is the offset from the desired dotted line. So you have this, you want the vehicle to go straight, but it will obviously not always go straight. It will keep on oscillating or like trying to like oscillate. So you need to find out what is that angle right here. So, and this is just explaining how it works. And another things to keep in mind is as you are doing all of that computation on your um on your computer, it takes it obviously takes time for it to like get done. And I mean, even though it's fast, like it's almost like milliseconds, but it's still time. So if you are running at high speed, by the time that the vehicle is done with the computation, the vehicle is not where it was at, like a few milliseconds ago. So because of that, you need to take into account like like a future trajectory of the vehicle, or like a little bit. So that's pretty much everything that you pretty much need to know for PID and wall following. And this is not the end of the lab, but the workshop. But yeah, so this is kind of like the end of the presentation. We can now kind of like go to the hands-on workshop part. I did create the step-by-step guide. Just go on. Does Can anyone access this website right now? Or, I don't know if you have it saved already by any chance. So go on that website. If you don't have it saved, you can just type tinyurl.com AI racer dash workshops, and it will take you there. Raise your hand if you're there already. Just trying to see. All right. All right, so just go on this. This is the current workshop we're on right now. And if you did not have VMware or Ubuntu, you can use that to do that. If you haven't installed ROS, you have that, the simulation as well. So these are the prereqs. But if you already have all of these, then you can go and click on the live canvas, and it will take you here. And just use a preview only, so it can maximize your view. So, of course, you can open VMware and kind of like start with it. It's pretty straightforward. Let me walk you through what you would need to do and where you need to stop. And as you're kind of like doing it on your own, since it's just pretty much a copy and paste for the most part, I will kind of like if you have any questions or if something is not working, then I'll kind of like let me know, and I'll also try to like see if I can get this vehicle to work. So so this part is just telling you about what I just said in the presentation, and it gives you like an example, and then you have to set up your workspace just like you would normally, and you need to create a package with the right dependencies, and make sure those are right, and you need to create the entry point for the wall follow node that we will create. And this is the starting code for it. It is not completed yet, but later it is kind of like a completed in the later steps. But once you have this code, test it to see if the setup works, and then complete the get error method. And this is the PID control method, or like the function. And then you can stop right here once you're done with that part and test it and see if it works on the simulation. And kind of like raise your hand or like just let me know if you have questions. Where are you at?
Right here.
Okay. So once you're there, scroll down. So basically, um, do you have VS Code installed at this by any chance?
VS Code.
Okay, so to make your life easier, go on Ubuntu software. You can go over there so you don't have to like hold it. Is anyone here using a Mac M1 or M2 or M3 or M4 M chip Mac?
Yeah.
You are? Okay. Anyone else? No? Okay. Do you have VS Code installed?
Yeah.
Okay, so you're straight. Anyone else who is on Windows who has VS Code installed on Linux? Okay, who does not have it? Just okay. You don't have it? VS Code on the virtual machine on VMware, like like when you like you have it. Okay, all right. So yeah, so just it's probably called it.
Did that last time too.
Is it called code? Let's give it a second. I don't know. Okay, so you see how it's not. Let's see if that would work. I know it's in there. Oh shit. There you go. See, I typed code and then yeah, install it.
Is there anything else in your download?
No, it should be just that. And it's not like you really need it. It just makes
Makes it easier.
yeah, you'll see. Like in the past lab where you just kind of like using Nano to copy and paste the code and editing the codes, something like that.
I was just doing it regularly, like it let me copy and paste from here like that, and then I just.
How did you create the file and you just kind of like follow through the instructions?
Yeah.
Okay. All right. So and then oh, it was this. All right. So let me see real quick. Okay. So what you can do is just type when you are inside of a directory or folder, you can just type code space and then dot, and it will open everything in there, but with VS Code. Just give it a second, I guess. And yeah, there you have it. So those are the folders. Have you used VS Code before or no?
No.
Okay, this is your first one. Okay. So those are like folders,
Hmm.
and those are files. And
Oh.
you can easily just edit the file here. You can ignore everything else, and once you're like edited, you just press Control S to
Oh.
save, and then yeah, you can go back to the terminal and do your thing for like to run them.
Run
Yeah.
your device from here.
So yeah, so basically here it says like ensure that package.xml has the right dependencies. So open package.xml. It's like yeah, and those are the dependencies like these four things.
Hmm.
Make sure that it like yours has it, which is it has it, but basically make sure
All
that
of
this
those.
looks like this.
Oh.
Yeah, that was the goal. Yeah. Okay, how are you doing? You doing good?
Yeah.
Doing good so far?
I think so. This just give me all of that though. I put this in VS Code, right?
Uh,
Okay, that's why I didn't put it in the right place. Whenever I open it, the file we just made isn't there.
oh, so what you can do is so like once you like create the package on terminal, right?
Is that the colcon or build?
So is that you just created that, right? Let me
Yeah.
see. Okay, so you can just do code dot, and then it should open that in VS Code.
Okay, perfect.
Yeah.
Thank you.
Mhm. You good? Everything's running good so far? Is everything running good for you so far?
I believe so.
Okay.
I think I'm just trying to follow this.
Oh, okay. You're trying to like set up the simulation?
Yeah.
Okay. That's good. If you like stuck somewhere, just let me know.
Okay.
Yeah. Looking good?
Yeah.
All right, bet. So basically, once you are done with um completing this function, so so you have this skeleton right here, but this function get error. See, it says like to do, so it's not implemented yet. And this function PID control, it's not implemented yet. So those those two steps that are followed is to implement the get error, which is right here. You could kind of just copy and paste if you want to, or try to understand it. And PID control function as well is like implemented. So note that when you like copy those function and put them here, make sure that you are make sure that you're using the right indentation. So it's like, because Python cares a lot about indentation. So make sure you indent like like everything else if you're just copying and pasting. And basically when I said to like stop right here, once you done implementing this function, you should you should start your simulation and then start this node. Basically, use calc and build to start this node and see if it works. And if you have issues like starting it, let me know. So yeah, that's what I mean by like stop right here. So test your node and like test it right here. All right, let me see this real quick. Huh?
How would you launch the simulator?
Say that again.
How would you launch the simulator?
Hold on, give me a second. Let me just plug this in real quick. Okay, so to launch the simulator, right? So what you need is, I'm assuming you did like the simulator workshop and it was running fine, right?
Mhm.
So if you look on files, right?
Mhm.
So this is where you currently, well, um, okay, it seems like I guess seems like you're missing a step.
Yeah. I mean, the simulation loaded up last time.
No, I'm saying like for this, uh, going back to this. Let's see. Okay, I think you didn't do this part. So basically, I mean it's not that big of a deal, because I can do it. But basically, this is just. I guess you didn't have that in created yes, probably. Okay, so ROS2 workspace is just a folder that we just created so we can easily have the nodes that we'll be creating later. So we can just create that real quick for you and then move the wall follow folder there. So to create it, mk there, um, ROS2 workspace, and then cd into going into there, and then create the source folder. And then you can just, instead of having to do the command, you can just go here and put this in here and put this inside the source folder. Alright. You might need to close this and reopen it as a terminal.
I think it's just an app then.
Mm,
I think it's just an app then.
okay. I thought you had it open, that's why. Mm. That's okay. I guess you didn't save that part. Make sure like you have the actual entry point right here.
Mhm.
You might have done it, but it didn't save. But because did you press Control S to save it? No.
Oh no. Oh,
Okay.
was I supposed to do that like at the beginning or at the end?
I mean, once you're done, you press Control S to actually save the file.
Okay.
Wait, so you might have not have.
Do I just do it all?
Yeah, you might need to if you didn't create it. Yeah. Oh.
Alright.
Okay, so you didn't create the files though. To create the node, create this file wall follow dash node.py.
Mm-hmm.
So this is where it needs to be inside that wall follow folder. You click on this folder and then create new file
Mm-hmm.
and then name it
That
what it's supposed to be
uh,
and then modify that file.
into into this. Put that in
Yeah.
there.
All right, that's cool. All right, let's see. All right. Is anyone here kind of like done and got it working? Is fully working?
It's like driving this on its own. Okay.
Oh, okay.
Just doing this part now.
Okay. All right. That's good. Where's you stop at?
Oh, I was right here.
Oh, okay, okay, yeah. You can continue if you want.
All right.
Yeah. Anyone else is done? Or like done with that part? Or if you stuck as well, you can kind of like let me know. All right, gotta go. All right, bet. Yep.
It's doing the same thing it did the other day.
Really?
Even I fix it, it still says no executable found.
Oh man.
This is I like did everything in the thing and then
Wait, save the setup file real quick. Press Control S to save it, and save that file too. Control S, and then try building it again and see.
okay.
There we go.
Thank you.
No problem. There's an option you can use like the dash symlink dash install. And yeah, so it's like yeah, it's kind of yeah, yeah, yeah. But look it up so you can have like the right um command if I'm not mistaken. Say that again.
You know what to do if the card doesn't load?
Oh, okay. So it depends on the car itself is not loading.
Yeah, all the parts aren't loading.
Oh shit.
You're all good.
Um, so there was like on that are you following like the instructions that I had, right?
The guy.
Yeah, the guide.
Yeah.
There's like one last thing. Sometimes did you end up running this
Yeah,
Yeah.
and you cock and bit everything and it wasn't loading still?
yeah. I just rebuilt.
Okay. Then let me see.
Is it because of the global status here?
I mean, shouldn't just cause let me see this. Uh, you probably run that command in the other terminal, I would assume. Let me see.
No, I ran it in that one. The Python one?
Yeah.
I ran it in that one. I did a lot of stuff though after that. I don't know if it's gonna.
You just copy it again and see.
There's no copy paste
Oh, it's
That's,
not.
that's what we were trying to figure out.
Oh,
right now.
damn.
The
Yeah.
only thing I
that's
found
tough.
about copy and paste was this. But
Okay. Some people were having that issue. I'm not gonna lie. But I don't know, cause for me and for a lot of other people, it just works. Copy and paste just works, and right off the bat.
was it? It's not just a Windows thing, or
No, it's not just a Windows thing.
It's,
Like,
yeah, it's every VM.
okay.
I think it's just okay. Wait, you take it. I'm trying to see if I can get it side by side.
Oh, I think you just said put it right there.
Okay, appreciate it. Mm. Python 3 pipe install. Yeah, it seems like it's already there. Just like you said. have VS Code installed by any chance? No.
Not too sure.
Okay. Installing VS Code just makes it easier to like troubleshoot and see.
Okay.
Since there's from my launch file,
It's fun.
since it does not contain that higher function generate launch description. But the function's on the top right there.
Did you like open though?
I'll do it again, but
Yeah, maybe just relaunch that. So,
Put in your password.
I know I hit out.
All right, that's fine. Did you run into any issue or you were good? Okay.
It's good, thank you.
All right, no problem.
both recording.
Then I would do this after the simulation, or is it?
So, basically, are you familiar with Frost already or no? No.
Not too much, no.
If you have you used it in the past at all? No.
I
No.
don't think I have. No.
Okay. So there's like this is the third workshop. Um. So the one that is like the most important would be like the first one to get used to Ross is just like know how it works.
Is that the
Um,
one that I saw that there was like a recording to? Or
Yeah. So I have all of the workshops recorded.
yeah.
Everything should be there. But if you just want to get to this one as fast as possible, you could just follow through it. Um,
But just familiarize myself with those.
yeah. So like if you go here, yeah. So this guide right here allow you to like get familiar with Frost, and then this is to install the simulation and also there was an automatic emergency braking system that we implemented. If you want, you can go through that as well. But this is not required for this. But the Ross one is a bit, it's kind of like really good to know.
Yeah.
But yeah, after that, that's pretty much what you got to do.
What step were you on for this?
Like for this one.
Yeah.
Um, so once you installed VS Code, to like help you like code like a workspace, you can just press code and then dot, and then it opens up. Just give it a while. It'll open up the folders in there. I'm assuming you're familiar with VS Code already or no? Have you used VS Code before? It's just a GUI. I mean, like a code editor.
I think I might have used it once.
Okay.
but I haven't used it.
What's your major, by the way?
Mechanical engineering.
Mechanical? Okay.
But like I'm like kind of like starting with like I have like dynamics.
Oh, okay. You like,
You have to take intro to C for that?
Yeah, I
Okay.
already took intro to C.
Oh,
Those
nice.
a little bit.
okay. Are you like a junior or?
Huh?
Are you a junior or?
Junior.
Okay.
Yeah.
So this is VS Code is just like a code editor, like file editor, whatever you want to call it.
Because I saw this uses like Python, and then
Yeah, you can use that too. Did you run into any issue when you were like installing all of um the regular F110 system when you had to do like a pipe install dot like dash E dot?
Mm-mm. I didn't have any issues like that. The
Yeah.
moment the map loaded, the car always loaded for me.
Yeah, I've never usually like I've never seen it like do that. Usually like the map wouldn't load.
Yeah, that's what was happening. I just fixed that, and then the car wasn't in there either.
Oh, okay. So like when you fix that, did you do anything else?
No, I literally just fixed the file. The file path is wrong.
Interesting, interesting, interesting. I'm trying to see what could we.
Yeah, it's weird because you copied and pasted it, right?
Yeah.
Yeah, so
This is loading. This is loading. This is loading. I'm gonna just try changing the map and see if that would do anything.
was the verification when you verified it? Oh, it's after. Yeah, that's good.
Oh, is it supposed to be green? I thought it meant like it's wrong.
And I think when you run grep, that means like you found it. That's what grep does. Yeah, weird.
I do my
Did you run this one before? But you're supposed to run like this whole build. It usually like saves it.
Is that also this one?
Yeah, it should be.
Oh, it's with the
Yeah,
Let's see. Delete, but at least
yeah, you can do the game before. And then not try to test it.
The only thing I could, I mean, I don't think it's that, but I know like um they are working on improving the simulation, right? And
Someone, I remember someone last year had the same problem. Like the map was loading, but the car wasn't loading. I don't remember what we did to fix it though. That's what I'm trying to recollect.
because if you see like the last command that I mentioned, like run, right? This was not there last year. You didn't need to run that.
Yeah.
But with like some updates that happen, I guess with either Ubuntu or something, and then it wouldn't work unless you change that dependency thing. Mm. Okay, so I guess the main one wasn't changed, but I know like there's this branch, right? This branch. I tried it. It seems like it's not working well as well. But I mean they didn't push it, so it wouldn't be that. Low key, my best bet would be like Loki try to like start over and see if it does the same thing. Just like let's see. Um, so it's about to be 9. You probably need to go. So what I would say is so um, first thing is try to. Okay, where did you? It's right here.
Yeah, because like then it knows then it's back off. That might have been the problem.
Yeah, just try starting over
Uh,
and see if that
yeah.
would work. But you would need to delete those two folders. Another thing would be to try to use a. Did you end up using like a virtual environment for that person?
Yeah,
Like,
they were in a
huh?
they were in what's it called, the Windows subserver
Um.
WSO.
Okay. Did you end up using like a Python VENV Python virtual environment virtual?
They weren't in the either. No, yeah, it was just they were just in WSO.
Okay. And you said you don't remember at all what you did to like help
No, maybe it was just they restarted it. They like started from scratch and
from scratch,
like just deleted the
including
gem and then
just deleting the folder, or because I don't like it's a lot of them are kind of like already installed. So I mean, you can just try it. But
oh no.
let's see. By the way, do we have to go right now, or because
No, I don't need to know. I was just curious what was going on.
yeah.
Yeah, I totally get it. And oh, I guess to help with the copy and paste, you can just open it here. Tiny URL .com AI eraser shops. Alright, so we are trying to, and you did install the dev tool for ROS, right? That's why you're able to call and build.
Yeah,
Okay.
Ross was fine.
It was fine. Everything was fine.
Nothing was there was no problem with that.
Okay.
Were you able to figure it out?
Yeah, we're still lost.
Is it still Lewis there?
Oh, okay. So you pulled it up and looked in there. So I can,
Yeah.
okay.
Oh, to help with the copy and paste, we just kind of like just use the
The regular Firefox, but then
Oh
Yeah.
yeah, I didn't think of that.
I didn't think about that.
That's definitely what I did.
I didn't think about that.
Put the password in. No, that's fine. I just thought about it too. Okay. How is senior design going?
It's chill, man. I'm just trying to get it over with now.
Yeah, that's why
Yeah,
that's how it goes.
the senioritis is finally kicked my ass. I really want out now.
What are you working on again?
We're doing like a autonomous software for um, the arm of a lunar rover. It's supposed to be able to like pick up pavers and like build structures out of it.
Are you in the lunar robotics project?
It's a Florida Space Institute project.
Oh,
Like that's our sponsor.
damn, we have two, probably like three senior design with lunar robotic stuff. Or like,
Really?
yeah, I mean that's not lunar robotics, but it's still kind of like similar.
Theirs was horrible. They had like their
Who?
entire GitHub was like undocumented.
Wait, which one?
The Florida Space Institute, because it was like a continuation of a previous project,
Uh,
and we were like given like nothing. So we spent like the first like 4 or 5 months just trying to figure everything out.
yeah, that sucks.
Are you like fixing everything?
If it doesn't work now, I really don't know.
You're in senior design
Yeah.
with a one.
Just crash everything and start over.
That might be the move.
Fall semester.
Oh, nice. Yeah. So you're in
Oh,
Coast-
actually, I didn't
or
fix
wait,
them.
which
Yeah,
one?
but
I already took CS.
You're still in Coast right now?
No, I already took it.
Oh, nice.
I'm in taking like discrete two and then like the CS selective.
Oh, nice. That's chill. Choose an easy project, bro.
Choose a what?
Choose an easy project.
Why you chose the hard one? Or did you choose or your group?
You like how it works is like they'll give you like the first like 2 weeks will just be presentations from all these sponsors, and then you rank which project that you like.
Oh,
So then you like rank like 20 of them,
and then you can randomly like
yeah.
choose it. Okay. Damn, so how's y'all project going?
It's going. It's not bad. It's just we had like very horrible documentation and stuff. So
Oh, you have to fix that up now.
yeah, so it's like a lot of our last semester is just playing catch up, and the beginning of this semester is also just catch up. So yeah, and then now we're like pressed to actually make progress.
Well, I mean, you still got a couple months though, right?
Yeah, it's just yeah, everyone's starting to slow down because we're all getting ready to graduate, so nobody wants to put in too much work anymore.
True.
yeah.
How's the street going?
Discrete. It's honestly not that bad. I really think it's gonna be worth it. I got like the good teacher.
Who you know?
You know Corey Pittman?
No, I've never heard.
I think
Is
he
he
just
good?
started teaching last semester. He's actually pretty good.
Oh, nice. Yeah, that matters a lot.
Who you have? Gerber?
I had Muhammad Ali.
Oh, there it is.
I thought everybody didn't have
Whoa.
Oh, okay.
Yeah, she's legit.
It works.
It worked?
Yeah.
Oh, nice.
I
You just restarted it?
Yeah, and also it took a while for it to like it was stock there. I don't know if maybe we had to wait.
Oh, did it just not load in potentially?
Yeah, yeah, it ended up loading. So I don't know.
Oh, nice.
Hmm.
But yeah.
That is not supposed to happen.
Oh, oh.
Oh, but it's working.
It's
It just
falling
It's
on the
working
outside.
at least. But
yeah, so that happens. You just have to adjust the PID values until it
Oh,
actually
okay.
stays.
Okay, so use the easier map. Use the other map that's included in there. That's like
This
way
one's
easy.
fine. It's gonna get stuck though. Yeah.
On that
Yeah,
one.
I mean the other one is like
The other one's more simply for it.
yeah, yeah, yeah. This one helps with like actually
Your program is working though. You just have to
yeah.
probably just switch maps and then adjust the PID values.
And that's in the node itself. The PID values is in the node itself.
I have a starting one. It should work, right? Did you have to adjust it?
Oh,
Yeah.
I guess you just have to probably just has to switch maps.
Yeah, just switch map and it should work. Cause
It's in the sim map. So if you make sure you cancel the sim.
where was
What's the other map called?
I? Spiegel something.
It's like Spielberg or something.
Yeah. Spiegel map.
Yeah, I'll find it. How's masters going, Israel? Chill.
Yeah, it's okay so far. The classes themselves are not hard. It's just I mean other things.
What was your major in undergrad?
In computer engineering. Yeah.
You came to UC then?
Yeah.
He so it's still because chill people know. Actually, just go back to the Jim Ross. So whenever you go back to the Chrome, if you want to like just do it from here, just do ls, open ls, and then that will show you like all the files there. So you can just go like cd. Is that a
Are you trying to find the map?
Yeah.
yeah, it's in the config file.
Yes,
It's that one.
Okay, there we go.
Let's restart that. You can just do cd.
Sim.
You type in cd.
Oh,
It's node. It'll get it.
Right, it's SRC.
Oh, never mind. Sorry.
CD dot.
yeah.
So,
SRC.
The comedy. Yeah, yeah, yeah. So it's just like just to help out, depending on like what you want to help with. Yeah, yeah, definitely. Which part? I mean, you probably applied already, right? But yeah, which one did you want to help out with? The marketing one. Okay, okay, okay. Yeah. Yeah. Do you know him? Hector. Okay, okay, yeah. But yeah, he's the coordinator for that. The coordinator for that. But yeah,
Simulation.
I'll keep you updated and like so you can kind of like help out.
So then just relaunch the node just to make sure it works. Nice. So I think what was going on is I think you were whenever you ran open build, were you adding extra words behind it? Oh, you weren't. Oh, weird.
Unless I was like copy and paste it from up here, then yeah, it was.
Oh yeah. So that's only it was only updating the default file.
Okay, I see.
Whenever you just run it just without any extra stuff, it just updates everything. That's very good.
Thank you.
Yeah.
Are you like pretty much done with everything? All right. So let me see. What I wanted to do is I wanted to see if I can
How's your stuff though?
like connect everything together, but it's not working right now.
Yeah, I think that's it's automatic braking, right? Right after they set up this time.
Yeah, that's the one you can you know try to do, but it's not required to do this lab, so you can just go straight to this lab.
Later if it's I know it's not late. So.
But oh, I'm assuming y'all gotta leave soon, right?
Yeah.
Y'all gotta.
Surely it's like 9 o'clock.
Yeah, it's like there's no point in trying to like freak. Yeah, 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 right now. So I guess let me see what can I do right now. Oh, just well, just like if you have some feedback, feel free to like give me some feedback or like what you would want we do more. But yeah, and if you haven't signed in, then sign in. And yeah, that's pretty much it for this workshop. Thank you for coming. See you guys next week. Note that next week on Wednesday there is a mechanical engineering workshop. They will kind of like just teach you how to like just build this simple frame. So if you want to like just come and learn, feel free to do that. I'll be there. I'm not gonna be the one teaching it. It's someone else. But yeah, feel free to come. We'll post it in the Discord.